This is the monthly review for semester 1. The subject is chemistry for grade 9. So we first looked at atoms and we said that they're spherical in shape and atoms contain protons, electrons and neutrons. So here we've got the atom and it's got a nucleus. So in the nucleus we have nucleons, which are protons and neutrons. And then we've got the electron cloud, which contains the electrons. Remember, protons are positive in charge, while neutrons are neutral and electrons are negative in charge. We saw how an atomic symbol looks like. So here we've got the proton number, which you can see here, it's the 6. That's normally the one that's at the bottom. We called this Z. We said that any particular element always contains the same number of protons. For example, hydrogen always contains 1 proton, carbon contains 6 protons, and magnesium atom always contains 12 protons. And if we change the proton number, that means we change the element. And this also is known as the atomic number, and it's always the smallest of the 2 numbers shown in most periodic tables. And remember, always write Z equals atomic number, which equals number of protons. Okay, and let's not forget this. This is the most important thing, that Z equals the atomic number, which equals the number of protons. This is the summary. So at the top here is where the mass number is located. So remember we said that electrons don't have mass, so therefore the mass of an atom is due to the number of protons and number of neutrons in the nucleus. Normally we give the symbol A for mass number. So A is the symbol that we give for mass number. Then we looked at the number of electrons, and an atomic symbol always looks like X, so that will be the symbol sign. And then A, which is the mass number, and Z, which is the atomic number or the number of protons. So normally we get the number of electrons from the Z. This is because in a neutral atom, the number of protons equals the number of electrons. So because atoms can gain or lose electrons, they don't normally gain or lose protons, we can take them from the Z. Normally, obviously, this will change if an atom has gained or lost electrons, and we'll look into this later. So to find the mass number, or the atomic number, or the number of neutrons, we can use these equations. So to find the mass number, we can add the proton number with the neutron number. To find the number of protons, we can minus the mass number from the number of neutrons. And to find the neutrons, we can minus the mass number from the proton number. And this one's one that we normally have. Now to look for a specific example, if we have, for example, Al, okay, which has a mass number of 27, and a proton number, atomic number, which is 13, we can use the equation n equals a minus z to find out the number of neutrons. So A is 27. Remember, it's always the bigger number. It's normally written on top. Minus 13, which is the number of protons, and this will equal 14. So the amount of neutrons that this element has is 14. So this is a summary of the atomic symbol. So the mass number is always represented by A, the atomic number is always represented by Z, and X is the element symbol. Remember that the A is the number of protons and neutrons because they have mass, and Z is the atomic number, which is the number of protons. So I'm going to give you an application. So I'm going to give you like a summary of everything that I just talked about. If I know an element for example, sodium, okay, and I tell you that sodium atomic symbol is Na. So let's write for you sodium. It is Na, okay. It's got the atomic number or the number of protons. So let me write for you number of protons is 11, and the mass number is 23. So if I'm going to do the atomic symbol for it, I'll write Na. I'll have normally the bigger number, so that's the mass number. We normally find it at the top. And the smaller number, which is the number of protons, we write it at the bottom. And that's how we write an atomic symbol. Now, to find the number of protons, remember we always write Z equals atomic number, which equals number of protons, which equals 11. To do the number of electrons, to find the number of electrons, we write in a neutral atom. Number of protons equals number of electrons. So therefore this also equals 11. And to find, I'm going to write it here for you. Okay, so to find the number of neutrons, so number of neutrons, remember neutrons don't have a charge, that's why we write 0. We use the equation we're trying to find neutrons, so it's N equals A minus Z. Remember A is here, so that is 23 minus Z, which is here, 11. So 23 minus 11 is 12. So this atom has 12 neutrons, 11 protons and 11 electrons. And then we looked at ions. So we said ions are formed is when an atom loses or gains electrons. So cations are positively charged ions. So these are the ones that have lost electrons. That means the positive is more than the negative. Okay, and anions are negatively charged ions. For example, we have, let's take sodium as an example again. Okay, we've got Na11. All right. Now, sodium normally loses an electron, and for it to lose an electron, it becomes a cation. Therefore, it has a positive charge. Okay, if it loses one electron, because it loses one electron, okay, we write it like this, so 11Na with a positive charge at the top. Similarly, for magnesium, if we have Mg, okay, just 12 here. Okay, now normally magnesium loses 2 electrons. Okay, because it's lost 2 electrons, that means there is 2 positive charges, so 2 more protons than electrons. So we just write it Mg2+. Now, examples of anions. For example, we have chlorine. Okay, so chlorine, it normally has 17 protons or electrons in a neutral atom. Now, chlorine normally gains an electron, so it normally gains an electron, so it becomes an anion. When it gains an electron, we've got like this negative charge. So normally we represent it as a minus on the top, just shown like this. We then looked at the charge of the nucleus, or the nuclear charge, and remember we said that the nuclear charge is abbreviated to Q nucleus. Remember, Q is charge. So we said that the nucleus contains the protons and neutrons, and remember the ones that have charge are the subatomic particle, which has charge is only the number of protons or the amount of protons. So we write Q nucleus, so we have to first say what's in the nucleus and how we find out the charge of the nucleus. So it's the number of protons times the charge of one proton, plus number of neutrons times the charge of one neutron. But remember, this is number of neutrons times charge of one neutron is always 0 because there's no charge for the neutrons. So as an example, this is an example for Al 2713. So the charge of the nucleus, if I ever give you a question, calculate the charge of the nucleus or something like that, you have to always write Q nucleus equals number of protons times charge of one proton plus number of neutrons times charge of one neutron. And remember, this is 0. So number of protons is 13. So it's the number here. It's 13 times, okay, the charge of one proton. And this is normally given, okay. So it is plus 1. And we usually put this in brackets. Remember, it's got a positive charge, so we always have to give this positive sign, so positive 13. We then looked at the charge of the cloud. Remember, the charge of the cloud is where we find electrons. So remember, we abbreviate to Q again. Here we see Q, which is charge of the electron of the cloud. So this is normally the number of electrons times the charge of one electron. Remember, in a neutral atom, the number of protons equals the number of electrons. So here's the number of protons, and in a neutral atom, this will also equal to the number of electrons. So for example, we're going to use aluminium again. So if I tell you to calculate the electron cloud charge, or a question that is similar, we look at the number of electrons. Here it's 13. Times charge of one electron, which is minus 1. This is always given. Times by minus 1. We put this in a bracket. Remember, the cloud is negatively charged, so we put minus 13. Okay, and this minus is very important. We then looked at the charge of the atom. Now remember, the charge of the atom is the charge of the nucleus and the charge of the cloud. So the nucleus contains protons and neutrons, so it's the charge of the protons plus the charge of the neutrons, and the electron cloud contains electrons. So remember that the charge of the neutrons is always 0, so it boils down to charge of the proton plus charge of the electrons. So we calculated the charge of the protons in the before, and we came up with, for aluminium 2713, we said it was plus 13, plus the charge of electrons, which we said before was minus 13, so the charge effectively is 0. Now this will only change in case of an ion, okay, because with an ion we lose electrons or we gain electrons. So if we lose electrons, there will be more positive charge for the atom, and if we gain electrons, there will be more of a negative charge around the atom. We then looked at atomic mass, and remember, atomic mass is the mass of one atom. So the mass of an atom is normally the mass of protons plus the mass of neutrons plus the mass of electrons. But remember, we said that electrons don't really have mass. It's negligible compared to the mass of neutrons and the mass of protons. So we put this 0. Okay, so the mass of an atom is due to the mass of protons, which we said was Z, and the mass of neutrons, which is N. Now the Z plus N is A, right? Remember, we always write an atomic representation like this: X, A, and Z. And we said A is the number of protons plus the number of neutrons. So A is normally what is the mass of the atom. So with Al as an example, that will be 27 AMU. We then looked at isotopes, and remember we said isotopes are atoms of the same element that have the same number of protons. As you can hear, they have the same number of protons, but different number of neutrons or different mass numbers. Here we can see the different mass numbers. Remember, we said that the combined percentage of isotopes is 100%, so 98.5% plus 1% is 99.5%, plus 0.5% is 100%. So if one of these are missing, we can always calculate the relative percentage abundance. We can also calculate the number of neutrons in each one using the equation n equals A minus Z. So for oxygen 16, A is 16 minus Z is 8, so this has 8 neutrons. 17 minus 8, this has 9 neutrons. And 18 minus 8, this has 10 neutrons. Now a question I can ask is which one has the highest or the heaviest isotope. So which one is the heaviest isotope? And this will be the heaviest isotope because it has the most number of neutrons. We then looked at electron configuration. So electrons are not randomly distributed, they actually are arranged in different energy levels or shells around the nucleus. First level has the symbol K and it can fit 2 electrons. Second level has the symbol L and it can fit 8 electrons. The third level has the symbol M and it can fit another 8 electrons. And the fourth level has the symbol N and it can fit 2 electrons. So how do you write electron configuration? As you can see at the bottom here. So hydrogen has got a Z or number of protons of 1. Remember, in a neutral atom, the number of protons equals the number of electrons. So number 1, that fills the first energy level, which is K. Okay, it only needs 1 electron. It can fit 2, but we only need 1. So we write K1. So this is how we write the electron configuration. Then we have sodium, which has 11 protons, therefore it has 11 electrons. So first we'll go to the first energy level, which is K. Now K can only fit 2, so we write K2. But we've got another 9 electrons, so we go to the next one, which is L. L can only fit 8 electrons, so we fill the whole of that energy level, so we write L8. So 8 plus 2 is 10, but we've got 11, so we go to the next energy level, which is M. Now it can fit 8, but we only need 1 more, so we write M1. Similar to 12mg, so 12 mg, so that was got 12 protons. So in a neutral atom, number of protons equals the number of electrons. Here we've got K2, so it fills the first energy level. Similarly to sodium, we've got another 10 electrons. We fill 8 in the L energy level. With 8 plus 2 is 10, but we've got 2 more electrons, so we go back next to the next one, M. Now M fits 8 electrons, but we only need 2, so we write M. As you can see here, it says group. Group have the same number of electrons in its outer energy shell. Now, this is the outer energy shell, K1. M1 for sodium and M2 for magnesium. As you can see, because it says 1, okay, that means it's in group 1, okay, for hydrogen. For sodium, which is Na, it says M1, okay, therefore it's also in group 1. So hydrogen and sodium both belong to the same group, which is group 1. Here we've got M2, so this belongs in group 2, as you can see here, okay. Rho, so the name is the same number of energy levels. So the energy levels is the KLMN. So this hydrogen has only K, so it's got 1 energy level, so it's in row 1. Sodium has KLM, okay, so K is an energy level, L is an energy level, and M is an energy level, so it belongs to row 3, okay. Similarly to magnesium, it has KLM. K is an energy level, L is an energy level, and M is an energy level, so therefore it's also in row 3. Valence electrons, they are the electrons in the last shell, okay? So, for example, in carbon-6, the electron configuration is K2L4, so we look at the last number here, so this has got 4 valence electrons. Oxygen 8 is K2L6, so this we look at the last number here, so this has got 6 valence electrons. And boron 5, the electron configuration is K2L3. We look at the last energy level here, and it's got 3, so it has 3 valence electrons. Lewis dot symbol is the chemical symbol surrounded by the valence electrons. So, for example, we have carbon 6, okay? So the electron configuration is K2L4. This has 4 valence electrons. So how do we do this? We've got carbon, so it's a chemical symbol, so the chemical symbol for carbon is C, surrounded by the valence electrons. So here we've got 1, 2, 3, 4. Okay, and this is how we draw a Lewis dot symbol. For oxygen, we have 8 electrons, so K2L6, and it's got, as you can see here, the last energy cell has 6 electrons, so therefore it's got 6 valence electrons. So what we do is we write oxygen, we do O for oxygen, and it's got 6 valence electrons, so 1, 2, 3, 4, okay, and then we put another 1, 5, 6. Okay, so this is how we draw it. For boron, it's got 3 valence electrons, as you can see here, because the last energy shell has 3 electrons, so it has 3 valence electrons. So what we do, we write the chemical symbol, which is B, and it's got 3 valence electrons. And this is how we write the Lewis dot symbol. So this is a summary of what we learnt this month or month and a half. I wish you all the best in your exams, and I hope you do well.